outer space. And it's really important that we learn how to grow food in space, because this is part of the idea of not only going to Mars, but being able to stay there, and the colonization of other planets. We need to be able to grow food, as well as if we want to travel further out into our solar system, we need to grow the food as we go. It costs about $10,000 for every pound we send to space. So you can imagine the resources we'd be saving if you only have to send up seeds instead of heavy materials. So these are some of the reasons why NASA is really interested in looking into growing food. And this is actually one of my favorite things I got to do, was see them initiate a new crop on the space station. So this is a picture from a live-time video conversation between an astronaut, Joe Okaba, on the space station, who's being guided on the ground by NASA's plant scientists on how to plant a new crop in the Veggie facility in space. So I woke up at 5 a.m. to go see this, because you're on astronaut time, which has a very strict schedule, and every 24-hour period, astronauts get 1 hour to themselves. And that's it. They get to sleep and eat and all of that, but it's all scheduled by NASA. So they have 1 hour. The rest of the time, they're doing things like this, research. And it's important to remember that astronauts can't be an expert in everything, right? We don't have any plant scientists in orbit right now. So that's why they need to have these conversations and be supported by these teams of people here on the ground who are experts and who can guide them in these projects. Another thing going on at the Kennedy Space Center is a project called Restore. So this is a robotics servicing mission designed to refuel satellites that are already in orbit that were never designed to be refueled. So essentially, imagine having a satellite orbiting our Earth. They need to create something that can dock with it while it's in motion and break into a fuel tank that was never supposed to be broken into, so they can extend the lifetimes of old satellites that would otherwise be useless if you were not refueling them. So I got to work on this project for only a day. I worked on this for a little bit, since it's really outside of my education position. So the picture on the right is from that experience. And on the left, you see where this is all taking place. The research happens in the Vehicle Assembly Building, or the VAB. By volume, that's one of the biggest buildings in the world. If looking at volume, you could fit 3.5 Empire State Buildings inside of it. And to give you a scale, that blue part of the American flag is about the size of a basketball court. So that's sort of what you're looking at there. And so this is so big because that's where NASA puts its rockets together. So the rockets that took us to the moon, all of the space shuttle missions, and the rockets that will take us to Mars, all are stacked inside of this building at the Kennedy Space Center. Another one of my favorite parts of it is called SwampWorks. So this is a robotics lab that does a lot of amazing research, but my favorite project is doing 3D printing. So we have some 3D printers over here, but it's not like what you see here. They actually have massive 3D printers that use essentially dirt, that they're testing to see if you can 3D print dirt into habitats for Mars. And so this is something really happening right now, which really just amazes me that we're at that point where we're planning out how to build our homes, and if we can make it from Martian soil and build the soil into 3D printed houses, so we don't need to bring building materials for living on Mars. So just like we don't want to have to bring all of the pre-made food, we want to be able to utilize the resources where we are. And so that's one of the projects happening right now at SwampWorks. The final thing I'll mention with the Kennedy Space Center is Orion. This is the brand new capsule that NASA is building that will be the vehicle that takes us to Mars. And so this will be launching from the Kennedy Space Center. However, this picture you see here is actually from NASA's Johnson Space Center, which is in Houston, Texas. And so it's there because that's where this giant pool is located. So this is the biggest indoor pool in the world, about 200 feet long and 40 feet deep. And it's so big because they have full-scale parts of the International Space Station models inside this pool. And we do this because astronauts need to figure out what it's like to work in microgravity. And the best way to do that here on planet Earth is in water. So they go scuba diving. All astronauts are required to become certified scuba divers before they can do anything else. And they go practice at this giant pool called the Neutral Buoyancy Lab. And so that's what you see here. Here is a model of the Orion capsule in the pool. So they're testing how we recover it. Once the astronauts come back from Mars, this capsule will land in the ocean. And so we have to have teams of people going out on the rescue mission to retrieve our astronauts. I also work for the NASA Goddard Space Flight Center, which is a really exciting place because there's a strong